A very good morning to all of you. Today I'll tell you something about fundamental notations that you'll be using while programming. I'll also introduce you to arrays. Now, when you are given a project or a program, you'll first decide the strategy that you will be following to solve it, whether you will follow the top-down or the bottom-up strategy. The top-down and bottom-up are strategies of information processing and knowledge ordering. It mostly involves software, but also other humanistic and scientific theories. In practice, they can be seen as a style of thinking and teaching. When you are given a program, you can decide whether you want to follow top-down approach or the bottom-up approach. In many cases, top-down is just a synonym of analysis. When you analyze something, you try to decompose it so that a complex problem becomes easy to understand. And bottom-up analysis is synthesis. So in top-down approach, you are breaking down a system to gain an insight into its compositional subsystem. You cannot follow a project, it is quite complex. It is better that you decompose it or you break it down into subsystems. If you feel that the subsystem is again complicated, you can further divide it into a next level of subsystem. You will go on dividing the subsystem further on till you get base elements, and this base element has to be a simple thing which you can code or program easily. This approach is called top-down approach, where a complex program or a project is broken down in subsystems till you get such base elements. You break it into such small programs which are very simple to code. The opposite of it is a bottom-up approach, which is piecing together systems. Earlier, you broke down a complex system into subsystems, whereas here you'll be piecing together the subsystems and you will give rise to grander systems. And this will continue till you reach the top. You're starting from the bottom and you'll reach the top. The elements are linked together to form larger subsystems which are further linked and linked. At many levels you go on linking the subsystems and a complete top level system is formed. So you see, the top-down and bottom-up approach are totally opposite. So whenever you start programming, you have to decide whether you want to follow the top-down strategy or the bottom-up strategy. Top-down programming is a programming style, the mainstay of traditional procedural languages, in which design begins. In the beginning, you will specify the complex pieces. Further, these complex pieces are divided into smaller pieces. Eventually, the components are specific enough to be coded and the program is written. This is the exact opposite of bottom-up programming approach, which is common in object-oriented languages like C++ or Java. Now, the technique for writing a program using top-down method is to write the main procedure that names all the functions that it will require. Later, the programming team looks at the requirements of each of these functions and the process is repeated, which means the main program is further divided into functions according to the needs. These compartmentalized subroutines will perform actions so simple they can be easily and concisely coded. When all the subroutines have been coded, the program is done. Now, what is the advantage of decomposing your program, or you can say the advantages of top-down programming? Now, when you decompose a program, you can give one subsystem to be coded by one person, the other subsystem to the other. So, you are separating the low-level work from the higher level objects, and this leads to a modular design. The higher level people are not considering what is going on at the lower level. They'll be just concerned with the output of the subsystem. Then there'll be fewer operation errors. It is less time consuming because there are many programmers that are involved. It's a big project, but each programmer is solving a part of it, a subsystem of it. So in a lesser time, you will be able to solve your problem. It's a teamwork. Very optimized way of processing, because each programmer has to apply his own knowledge and experience to just a part, to just a module of the project, and so the project is an optimized one. It is very easy to maintain. Now, the only disadvantage of top-down programming is that functionality, if there is functionality is not present at low-level objects, it cannot be present at the higher levels. That is the only disadvantage of top-down programming. It has to be, the functionality has to be inserted into low-level objects. Only if the lower-level functions are working properly and then it returns canned answers, manually constructed objects, then the upper levels will be functional. Otherwise, it is going to be incomplete. The opposite of top-down is bottom-up approach. In bottom-up approach, the individual base elements are first specified. Earlier, you first specified the main program and then the subsystems, but in this, the base elements are first specified in greater detail. These elements, when they are specified, they are linked together and they form larger subsystems. These are again linked together. At many levels, this thing is continued till a complete top-level system is formed. So this strategy resembles a seed model, where the beginnings are very small, but eventually the complexity increases and the completeness increases. In top-down, initially it is complex and then you break it down into easier functions, but here you are starting with the base elements. The easier functions are solved first and then they are put together to form larger subsystems. Now the next concept that you will be following when you are doing programming is structured programming. Now structured programming is basically used because we want to avoid the use of go-to statement. Generally, when you are stuck in a program, you tend to write go-to and you just jump to some other position. So this has to be reduced. It has to be totally avoided, but we'll try to reduce it using structured programming. So structured programming is a subset or a subdiscipline of procedural programming, and which is one of the major programming paradigms. Structured programs are often composed of simple hierarchical program flow structures. There are three structures that are used in structured programming. The first is concatenation. Concatenation is simply a sequence of statements and they have to be executed in order. You go from the first instruction to the second, then to the third, and so on. So you are going in order. The sequence is followed. This structure is known as concatenation. The next structure is selection. In selection, one of the number of statements is executed. There are two and you have to decide which has to be followed. So the example over here is if then else. अगर ये condition follow होती है तो आपने ये instruction execute करना है. अगर ये नहीं होती है तो आपको क्या करना है? So if there is this kind of selection between the statement which has to be executed, then it is known as selection. The last structure that you are going to use is repetition. Now repetition is a statement that is executed until the program reaches a certain state, or operations are applied to every element of a collection. Suppose I want to display a list of numbers. So all the numbers have to be displayed. The same statement, that is print, whatever the variable is, has to be repeated for all the numbers. So one statement is written and this statement is repeated every time till the operation is applied to every element of the collection. So this is known as repetition. The example of it is while, repeat, for, or do until. These are the examples that we'll be studying further. Often it is recommended that each loop should have only one entry point and one exit point. Now, when you are working in C, you will be using the following data types. Integer, which is written as int, character, which is written as char, floating point, float, double precision floating point, where you will define it as double, and void. Now the range of values that these data types can take is, for character it is from -128 to 127, for integers, for float, and for double. So when you are defining it in C, you will write char, int, float, or double. Any variable that you are going to use in C has to be defined by specifying the type. What is the type of variable that you are using in your program? So the first type is integer. What is an integer? Suppose that you are going to use whole numbers in your program, you will define it as integers. Integers are whole numbers with a machine-dependent range of values. A good programming language has to support the programmer by giving a control on a range of numbers and storage space. Suppose you are going to use a variable which is going to store real number, a number with decimal points which has got fractional values, which is not a whole number. You will define it as float. Floating point number represents a real number with 6 digits precision. Floating point numbers are denoted by the keyword float. You will write float and then the name of the variable that you want to store a real value. When the accuracy of floating point number is insufficient, you have a bigger number, and the number of decimals is not sufficient, then you will use the data type double. To define the variable, you will write double in front of it. It is just used for longer precision. Then void data type. With this data type, you can specify the type of a function. What is the type of function that you are using? It is a good practice to avoid functions that do not return any values to the calling function. So make it a practice to always have some value returning from the calling function. Then the next is character type. A single character can be defined as character type data. Characters are usually stored in 8 bits of internal storage. The qualifier signed or unsigned can be explicitly applied to char. Every variable that you are going to use in a program has to be declared to the compiler. So before beginning the program, in the beginning itself, you will specify the name of all the variables that the program will be using, so that the compiler can do two things. This declaration of yours will do two things. It will tell the compiler the name of the variable, and it will specify what type of data the variable will hold. So there are two things. You have to specify the name and the type. So the format is data type की जगह पे int, char, float, double इस तरह से कुछ आएगा, और आगे आपकी variables की list, and it has to be ended with a semicolon. V1, V2, V3 are variable names. The variables, if you are specifying more than one variables, they have to be separated by commas. A declaration has to be ended with a semicolon. Suppose that I want a variable sum which will have only whole numbers. I'll specify it as int sum. So this sum is an integer type of variable which can hold only whole numbers, no real numbers. Another two variables, number and salary, are again storing integers, or you can say whole numbers. अगर आपको कोई रियल नंबर स्टोर करना है, जैसे एवरेज आप किसी 3 या 4 नंबर का एवरेज निकालते हो तो ज़्यादातर उसमें डेसिमल पॉइंट आता है. It's a real number, it's having fractions, so you will define it as double. You can also define it as float, but if you want better precision, you specify it as double. Defining symbolic constants. Now suppose you have some constant value, then you can define it as a preprocessor statement and use it in the program as any other constant value. So you have to define it as hash define whatever the name that you are giving to the constant and value of constant. तो पूरे प्रोग्राम में इस सिंबॉलिक नेम की वैल्यू यही रहेगी. ठीक है, मैंने यहाँ पे डिफाइन किया है हैश डिफाइन मार्क्स 100. सो थ्रू आउट द प्रोग्राम आई विल wherever I put marks, उसकी वैल्यू अपने आप हो जाएगी